Hello, my name is Javier Gutierrez. I'm an product marketing manager at National Instruments. The purpose of this quick video is to show you a demo on how to use the control design and simulation module in LabVIEW. So the very first thing I'm going to do is I'm going to open a new VI, and as any VI in LabVIEW, it has two screens: the front panel, where I'm going to have my user interface, and my block diagram, where I'm going to have my my code. So I'm going to right click, I'm going to use the control design simulation, I'm going to simulation, and then I'm going to hold this. So the very first thing I'm going to do is I'm going to draw a simulation loop. And the simulation loop is the main element to run ODE solvers or dynamic simulations in LabVIEW. I'm going to build a small control system, so this signal generator is going to be my set point. Here's where I'm going to have my feedback. I'm going to create a very simple controller, so it's going to be a just proportional. Let me also drop a block for my plant. I'm going to use a transfer function. And I want to see the results. So what I'm going to do is I'm going to go and use the SimTime waveform under Graph Utilities. So let's wire this up. Let me close my looping here. And I'm going to set up the different blocks. So I'm going to double click here. Well, in this case, I'm going to leave everything as default. So initial time is 0, final time or final value is 1, step time, or the time where we're going to see the change, is going to be 1, and you can see the preview in here. Here for my controller, actually I want to be able to change this gain interactively. So what I'm going to do is, instead of defining in this wizard or in this box, what I'm going to expose is a terminal, so I can feed that from my front panel. So now if I go in here, you see how my terminal is created. So right click, create, and it's going to be a control. And that's the gain for my controller. If I now go and double click to my transfer function block, what I'm going to define is the transfer function. So let's put, this is going to be 15. This is going to be 4, and there's a number of ways to define this block. In this case, I'm just putting the different coefficients. I could create it from different blocks in LabVIEW. I can copy and paste. I can save. I can load. So there's just a quick way to define the transfer function. Let's take a look at the simulation parameters. So I will double click into this part where my configuration pane is, and I see all the different options to change or to define my simulation. So I have my initial time, end time, I have a number of solvers, and the different parameters for my solver. I'm going to leave everything as default. So now I'm going to go to my block diagram, so my front panel, and I'm going to create my user interface. Maybe let's change this to proportional gain. Maybe let's make this a little bit bigger so we can read that better. Actually, let's make this one also a little bit bigger. And let's run the VI. So I run my VI and see my simulation. I don't like this plot. It's a little bit too simple for my taste. So let me change this to my response. Let's also make this a little bit more bigger. I'm hitting Control plus, so that's a quick shortcut to change the font. Or also I want this to be a little bit more wider. Probably let's change the color and have it in probably yellow. Now, actually, I can now change my gain. Let's see what happens if I put a 2. So my simulation changes. Actually, let me freeze the Y scale, so you can see the different changes. And I'm going to run this continuously, so we can see what the effects of the proportional gain is in my system. 2, 3, 4, etc. I'm going to leave it probably here at 3. Now, so I'm using simulation time. Let's say I want to use the real world timing. So what I can do is I can double click into my configuration pane, and I'm going to, first of all, I'm going to use a fixed step solver, RK1. I'm going to run this every 10 milliseconds. And under timing parameters, I'm going to define what's going to be the source of my real world timing. In this case, I have my Windows clock, I have my CPU clock. I can either use an external clock. I'm going to use my OS clock, and actually I'm going to check this one, auto period. So LabVIEW will tell me how many clocks to actually drive my simulation. I say OK, and if I run this again, now the simulation is going to actually take 10 seconds, which is the timing that we have defined from the beginning.